So I'm going to talk about my package, OhMyREPL, and in short, it's a package that tries to make the REPL a little bit more fancy. So a bit of an outline. First, I'll talk a little bit about the standard JuliaREPL and some focus on the new stuff in 0.6. The reason for this is that a few things that used to be in OhMyREPL got moved to base in 0.6, so I want to talk about these. Then we'll look a little bit on the package, see a little bit how it works on the inside. I'll try to do a bit of a demo of the features in it, and then a bit of summary. So let's first look at the JuliaREPL. Just so we're on the same page here, REPL stands for read, eval, print, loop, and it's what comes up when you start Julia in the normal way, basically. So it's been written in Julia since March 2014, so about 3 years ago. I wasn't around then with Julia, but I think before that there was some C library that they used. And I think Kino Fisher had this JuliaREPL in a package, and then it got moved into base at that point. And it has a lot of features compared to many REPLs that come with other programming languages. So for example, it has your history, it has different types of search modes, key bindings you can change, tab completion, and it's also impressively extensible. So for example, the rcall package for calling it to R, it has this REPL mode, so it's basically that you have an REPL inside the JuliaREPL. And there's some color customization. You can change the prompt color and text color, but it's not that much, so maybe that's where my package comes in. So let's take a little bit of focus on the 0.6 new features. So one of them is what I call prompt pasting. And basically, it's quite common with code snippets in the while that starts with the Julia prompt. So for example, we have in the doc tests, or when people have copied code from a REPL session. So as an example, I put this here from a doc test. You can see that we have the JuliaREPL there in the beginning, and we also have some output. And usually when you read a doc test, you want to run the code yourself. So previously, it was kind of annoying because you had to manually scrub this prompt away. You had to manually remove the output, and then finally you could copy-paste it into the REPL. Right now, we detect the Julia prompt, and we figure out that, OK, you're copying something that has a Julia prompt. We can remove it. We figure out what the output is. We remove that one. So you can just take this code, for example, and just copy-paste it into the REPL, and it should just work. Now, another thing that's new in 0.6 are the stack traces. So I don't know, people have been on 0.6 kind of long now, so maybe you don't remember this, but this is how it used to look. It's kind of red. And I'm of the opinion that if you use color, you should use it to highlight something, pretty much. I mean, sure, you're highlighting here that there's an error going on, but it's just a bit too red. So that was changed to something like this in 0.6. So there's a few things here I want to point out. First, the stack trace is no longer in red, as you can see. There's also, the stack trace is also numbered, so you can easily, when you talk to someone else about something, you can say like, oh, it's on stack trace 4, for example. It's easier to refer to it. It's also, we try to make the important stuff stick out a bit more. So for example, the function name and where it is, so the file name and the line number are here highlighted a bit more, because it's usually what you're interested in. So the types of the arguments to the function is sometimes important, but most often I would say not, so therefore that's why they're not highlighted. And what you can also do is after you've seen a stack trace, you can enter this stack trace number, press a shortcut, Control-Q, and it will jump to that, where the location of that stack frame is inside your editor. And I will demo that later. And furthermore, you can also do a bit of customization of this stack trace. So there's these two environment variables that you can change the color of the function and also of the file name and the line number. OK, so let's move on to OhMyREPL then. So in OhMyREPL, I have something called passes. And a pass is something that modifies the color or the style of stuff you enter into the REPLs. So the classical example is syntax highlighting here. We also have something called bracket highlighting or active bracket highlighting. It tries to show inside what bracket you are right now by highlighting these. You see now we're inside the parentheses here, so I'm highlighting the active one. And also something called rainbow brackets, which was a feature I found in a VS Code plugin. And what it does is that it matches colors on matching brackets as well. So you can see we have the parentheses to the left, which is matched to the parentheses on the very right with the same color. There's a few other features as well, which one is what I call bracket completion, which is if you open a bracket, we automatically insert an end bracket, and we put the cursor in the middle there. Some people think this is good, some people don't like it, so it's easily to toggle on and off. And finally, there's also a feature I call prompt changing. It's possible to change the input prompt in Julia, but it's a bit tricky, so there's an interface here that makes it easier. And furthermore, you can also add an output prompt. So you see these red angles here that comes appended to the output. So let's say we want to have a syntax highlighter in the REPL. What do we need then? Well, the first thing we need is some sort of tokenizer or lexer. So therefore, I created tokenize.jl, which tries to lex Julia code. Secondly, it would be nice if we have a nice interface for colors in the terminal. There is some support for that in base, but I think it's a bit rudimentary for the stuff I wanted to use it for, so I created this crayons.jl, and we will look at those packages now a little bit closer. So what is tokenization then? Basically, you take a piece of source code and you try to split that up into words with meaning, so to say. So in the figure here, we can see I am tokenizing this function that returns something, and you can see the list of tokens that it returns. On the left-hand side, we see the rows and columns where the tokens start and end. In the middle, we see what type of token it is. So the very first one, we have the function, which is a keyword. Then we have white space. Then we had an identifier, and so on. So we have some meaning of what these words mean now. And since I want to use this inside the REPL, which is an interactive use, it has to be non-error throwing. It would be kind of annoying if you just made a syntax error or something and an error pops up while you're typing your code. So therefore, if you look at the figure again, you see the return value there. It's actually invalid syntax. It has 1.1.1. So if you try to write that in the REPL, press enter, it will complain about that the syntax is wrong. So therefore, I made a designated error token to represent these type of errors. So ideally, this tokenize should never throw an error. It should do as good as it can, and when it finds a problem, it should have this error token instead. I also want it to be round-trippable. So basically, from this token vector, I want to exactly be able to go back to my original source code. So what we need to do then is, for example, we need to keep all the white space in there. And this tokenize package is the backend for one of the new CSD parser, which is the backend for the VS Code Julia plugin, which there will be a talk about later. And it also, I'm not sure exactly what it does, but it does some sort of module detection in Juno as well. So it has a hand there too. So crayons then. For those of you who don't know, the way you print color text in a terminal is by having these sort of ANSI codes, they're called. So in this example here, I write this ANSI code and then blue text. And this ANSI code sets up the terminal so that it's actually written in blue. So it's basically strings that you're doing. But it would be nice to have a better, like higher level system for terminal colors than just raw strings when you have to manipulate them a lot. So in crayons then, you can create one of these crayons. The very first here, I set it to a certain foreground, light red here, and I set it to blue. And what's shown after that is the ANSI code of what would be something printed in light red with foreground and bold. And then we can use call overloading to make any text in that color and style. And for the sea green here, as you see, I can also enter a foreground as an RGB tuple. And here I also show the underline keyword. And not all terminals supports this RGB style, 24-bit colors. For example, Windows, I don't think it will work there. And what you can also do is you can nest these things. So as you see in the outermost, I have the red, And then inside the red, the call overloading, I have the green crayon. And then finally, we print red again. And you can also multiply two crayons together, which basically means that you take the features from both crayons and you merge it into one. Now, there's one thing that's, let's say you have two crayons that both set the foreground. What do you do then? Well, here it's the last crayon that, if two crayons are competing, it's the last one that takes determines what it is. So here, both of the crayons determine the foreground, but the red is the last in the multiplication, so the result is red. But as you can see, the green one has an underline, but the red one does not have an underline. So the mixture of the two also has an underline. And in crayons, you can also do some testing with your terminals to see what colors it supports. So first you have 16 default system colors. That should work pretty much everywhere you have a terminal. You have another option of doing 256 colors. So then you have first the 16 system color. Then you have a 6 by 6 by 6 color cube. And then finally you have a sort of a grayscale ramp. So in total, 256 colors. And finally, you can also check if your terminal supports 24-bit color mode. And you can also check what kind of styles you have. So if you have blue, there's these kind of not so well supported keywords like faint. Blink, I don't think we should go back to blink. People remember the websites a while ago, so probably don't want to use blink in a color scheme. And yeah. So now we have pretty much everything we need. So how does OhMyREPL work then? So let's say we have entered something in the REPL here. I have a simple function that takes an argument, something like that. And we also have a cursor position, which is where our cursor is right now in the REPL. So the first thing we do is we tokenize the input string. So that gives us a vector of tokens. And then on this token vector, for each token, we assign a crayon to that token. So I have three passes here, the syntax highlighting, the active brackets, and the rainbow brackets. So the syntax highlighting, it goes through the tokens, and it does what it wants. It says, okay, the function token should have this color, and so on. And then, completely independently, the active bracket pass does the same thing. And you can see here that the cursor position happened to be inside this square root function. So this is where the brackets are a bit more bold there. And then the rainbow brackets does its own thing. It matches matching brackets and put those to the same color. And then finally, when all the passes have done their thing, we do the merging of this with this multiplication, as I said. So this would be the final result that is shown in the REPL. So here you have all the syntax highlighting, you have the bolded brackets where the cursor is, and you have the colored brackets for how they're matched. Okay. So let's try a bit of demoing now then. So first, I want to show you the new stack traces. So let's say we make a string and we index it out of bounds. So now we can jump to these stack frames by just entering 2 and then Control-Q, and it will open in your editor where that stack frame is. So here we went to the getIndex for this abstract string type. And if I press 1, I get to where the error is actually thrown here. So it's a kind of nice way when you have an error and you quickly want to go through the call stack and see how everything looks and how it is like that. Okay, so prompt pasting then. This is the example I had in the slides, where before you would have to remove the prompts and the output. And now you can just paste it straight in. And especially for doc tests, I like these, because all doc tests have the output and the prompts, and the output can sometimes be a bit long, so now you can just test it straight away. And you can see now if I type something, there's no syntax highlighting and there's no rainbow brackets or anything. And the reason because of this is because I've disabled all the passes right now. So you can see here that all the 3 passes are disabled. So let's enable one of them. So now I enable the bracket highlighter pass. So you can see now that when I move my cursor, different brackets get highlighted, and there are ones where the cursor is inside. So I kind of like this thing because sometimes it's hard to find the matching bracket of where you are. Okay, so now I enable the rainbow brackets, so let's type some brackets again. So you can see here that both the rainbow brackets and the active bracket highlighter is active right now. So it both shows me in bold and underline where I am, and it also highlights matching brackets. So, and also if you put too many closing brackets, it shows that in the red, because then you've probably done something wrong if you have too many closing brackets. And to show you this automatic bracket insertion, we can do something like this. And if you delete it, then yeah, it sort of go back like that. And finally, let's enable the syntax highlighter. So now if I write some function, something like this, you can see that there's syntax highlighting active. And just to type some random things, you can have symbols and strings like that. And there are a few color schemes implemented. So the reason why there's so many is right now I have that I have a separate color scheme if you support 16 colors, if you support 256 colors, or if the terminal supports 24-bit colors. So right now the default is that it's using this Monokai color scheme, but let's swap to something else. Oh yeah, I can test any color scheme with this test color scheme function. So for example, I can test the tomorrow night bright color scheme like that. And we can set it like that. So now the tomorrow night color scheme is set. So you see now that the syntax highlighting is a bit different. And I thought we would do an interesting experiment in generating a random color scheme. So first I have to just import some stuff. And then I define a function that creates a random crayon then. So you can see here I'm adding a background with some probability, and I also have a random number that's in this range for the color, same for the foreground and bold and so on. So we can now generate some random crayons. There's a lot of white ones in a row. Okay, it seems to work. And now I want to generate a random color scheme. So I can create a new color scheme, and then for each of these sort of tokens or symbols, comments, I simply assign a random crayon to them. And then I return the color scheme. Okay, so now I'm going to call this create random color scheme function, and I'm going to test it to see how it looks. So maybe not that one. Most color schemes are kind of bad, actually. Okay, let's go with this one then. So I'm going to add this color scheme to the list of color schemes, and I'm going to set it to this one. Okay, so let's try it out. Pretty nice. But seriously, let's go back to the standard. Okay, now we're good. Oh yeah, so now prompt changing then, when I said you can change the input prompt and the output prompt. So let's first change the input prompt to just be the version of Julia right now. And let's make it in blue. So now we have the prompt as I'm currently on 060, so that's what the prompt shows. And right now, if I evaluate something, it just shows the evaluated expression. But then, for example, the IPython notebook, they have this little output prompt as well, which I think is kind of nice. So I can add this output prompt, so just make so any string and then the color of it. And now if I evaluate something, there's this little output prompt as well. Question?
Can you print something? Will it not?
So it's only if you're, like, if the REPL is showing something that the output prompt gets there.
Does your copy and paste respect all that?
You're getting ahead of yourself, which is what I have here. Prompt pasting still works. So here I have something that I wrote before when I have changed my terminal. So I have, yeah, the terminal I've set here and something. And I also have an output prompt, the one I set. So now I can prompt pasting still works. So I think that was all for the demo. Oh. So a bit of summary and acknowledgements. I presented my package, OhMyREPL. It's there to customize the REPL experience. So there's two packages that came out of this one. One is called Tokenize, which is for lexing of Julia code. And I'm happy that it found some uses outside OhMyREPL. And the second one is Crayons. It's a package for dealing with colors in the terminal. And I want to especially thank Zach Nugent and Sebastian Fitzner for all the bugs fixes they made to Tokenize. And everyone else who's filed issues and pull requests from my packages. I think I have quite a lot of time left, so hopefully there's some questions or comments if you try to use the package. Thank you.